Hey,
Hey,
good
hi.
morning, good afternoon.
Good afternoon here. I do not know. It's early morning over there or midday?
No, it's 11 o'clock in the morning, so not
Ah,
early, but it's still morning for me. Good afternoon, Mustafa.
thank you so much. Good morning, Remco, at your side.
Thank you.
Okay, I think we are on time. Absolutely. Thank you so much, Remco, for joining. Thanks for giving us the opportunity to have expert on data vault because this is one of the topic which I haven't implemented yet.
Hmm.
So it's good to hear from people who really have implemented it because until unless it doesn't go under your hand, everything is theoretical.
Yeah.
So before we go into it, we would like to welcome you and we'll give you the floor to introduce yourself to our audience. There you go. Cheers.
Okay. Well, again, thank you for having me, Mustafa. My name is Remke Broekmans. I live in the Netherlands, near Rotterdam, uh, working for Genesee Academy, which is the organization which are delivering Data Vault training and Elm training worldwide, including advice, and we review models. So, and I'm working there together with my business partner Hans Hulken to make sure that we are able to offer our training and our expertise over all the world. So, do a lot of training myself. This week I happened to do a Data Vault certification training for a very enthusiastic group of 19 people here in the Netherlands. So still going strong, doing a lot of fun. So I'm a data modeling guy, like data modeling, like talking about data modeling. So that's why this podcast will be a perfect fit, I guess, because we want to talk data, right?
Yes, absolutely. We want to talk about data.
Yeah,
And this is one of my those podcasts where I did not prepare any questionnaire
yeah,
because
that's cool.
yeah, because we can talk. I can talk on data, especially when it talk about data modeling and proper data thing. Then
Yeah,
I don't need questionnaire.
yeah,
Okay,
yeah,
awesome, awesome. Uh, I think let's start with basics. We have this 60 minutes podcast. I
yeah.
will try to wind it up. I try to justify it so our audience can really understand what data vault is along with me. So I think let's
Okay.
start with very basics where data vault started, when it started, who invented, very basic stuff, and then I will go into technicalities.
Yeah, okay. That's I think it's a very cool question. I'm going to take one step further even back. When you look at history of data modeling in I think worldwide even, remember when we started up with the first computers going to be more and more used, all the data, all the information was stored in file systems. Uh, and then at a certain moment in time, somewhere around the 50s, 60s, Boyce and Cott came up with something. Let's store this information in database tables. So they created the tables and they say, oh, there's a primary key and a foreign key. So they create relational tables, which we now know in the end as third normal form as the basic idea.
Hmm.
So what happened? We started storing data in database tables.
Mhm.
And then every single implementation. So we had some transactional system, logistic systems, finance systems, customer systems. They all had their own database. And then, of course, somewhere around the 80s, there was a guy, Bill Inman, and he said, hmm, I have data here in a database, data there in a database, data there in a database. My customers asking me, can I combine that information? So he came up with the idea about what we now know as data warehousing. Integrate all the data together into one system to be able to report out of it, to make that combined, integrated information. And the only way he knew how to model that data at by the time was using third normal form, which was never meant to do something like storing historical information, keeping track of history or integration. But that was the only basically available approach for modeling your data. And then, of course, later on, Ralph Kimball came and said, if I'm talking to my customers, they always said, I want to know something, and there are different angles to look at what I want to know. What we now know as star modeling or dimensional modeling, right? That's basically what he's coming up. But it was very good for reporting, less for integration over different systems. Because what Ralph Kimball said, it's all about the department first and then the next one. And oh, we want integration. Let's combine dimensions between the finance department and the marketing dimension so we can conform dimensions, kind of mimicking integration. And I know there are different people thinking, yeah, this works fine. But in the end, it was still one table where all the information went in. As soon as there was a change coming, we want more information, more attributes, whatever. Same with third normal form. It's a hard time to capture those changes. Capturing change is the hardest thing there is. And then around 2000, 99, 98, 2000, there are a couple of people and they came up with the same idea. What if I can make a disconnect between the things that are changing and the things that are non-changing? Because whenever there's a change coming, I only have to worry about that part. And the idea was the same. What is never going to change? Identifiers, business keys. They are not changing, right? If you are a consultant, you get a consultant ID or employee ID, whatever, and that's going to stay. Whatever you're going to do, your contract is ended, or you're changing your address, whatever. It's just context, how we see you as a person. But your identifier stays the same. Also, your relationships are staying the same. The only thing what we can say, there is we have a different way of looking at that relationship. So the identifiers and the relationships stay the same all over. The only thing we're changing is context. So that's the basic idea behind what we now know as ensemble modeling. And Dan Lindseth is the one, he called it data vault. He said, let's store that identifier in a hub, relationships in links, and context in what we now know as satellites. So he's breaking up, call it unified ecosystem, breaking up. We got one big entity and we say, let's store the identifier separate from the relationship, separate from the context. In Sweden, we had a couple of guys. One guy was Poe Eriksson, and he came up with what we now know as focal point modeling, which looks really similar like data vault modeling, but just a little bit different. And the difference is how they store the context, how they store the thing that's changing.
What is that term? Sorry, can you repeat that term, new term you just mentioned?
Focal point modeling.
Focal point modeling. Oh, I haven't yet heard about this one. Thanks.
No surprise. You're not from Stockholm. It's very big in Stockholm area.
Okay.
But basically, it's doing the same as what data vault is doing. I'm storing the identifiers and the relationships separate from identifiers separate from relationships, separate from context.
Okay.
And how they store identifiers and relationships is basically the same with what they do in data vault modeling. They're calling it differently. They're calling it not a hub, but they call it focal. The relationships are stored in links, and same as we call it in data vault. But the difference is how they store the context.
What about Papini Bridge is also there? Papini Bridge also do something.
Yeah, it's kind of different angle.
Yeah. Okay, please continue. I don't want to stop you. Yeah.
No worries. There's also another guy in Stockholm, worked for the University of Stockholm by the time, was Lars Rumbeck, and he came up with something called anchor modeling. Anchor modeling is basically doing the same. We are storing identifiers separate from relationships, and he said the identifiers, we store them in anchors, relationships going to be ties. And the big difference between data vault and anchor modeling is, anchor modeling says every single attribute is going to be stored in its own table.
Okay.
You get a lot of tables.
Yes.
Which is not an issue, because as Lars would emphasize on that one, said you never ever have to change the table. So every change is coming is either going, I'm not stop loading this information in this table, or I'm going to have a new table. From a modeling perspective, that's very cool, because what's the hard part in data modeling is not creating the data model. I can create a perfect 100% correct third normal form data model for a data warehouse. I can create a 100% perfect data dimensional modeling for a data warehouse. Perfectly fine. As long as there's no change, it works. But as soon as there's a change, I need to do some stuff. And around 2000, when all the ensemble modeling patterns came up, so data vault, anchor modeling, focal point modeling, the idea was we need to be more agile. We need to be more flexible. At the same token, we need to be able to store all our data fully auditable and traceable. Remember, in the period of time, there was also in US, Enron was scandal was taking place where they altered history. And the thing which they want to do, say, as Sarbanes-Oxley Act is coming out of that one, we need to be 100% sure if we see data on a report, since when do we know this information and where did it come from? So that traceability and auditability is built in, glued in by design in all of the ensemble patterns, including data vault. But since we are here to talk data vault modeling, right? So data vault kind of starting off in 2000 and it evolved over time. Like all modeling patterns, you started with an idea and then you're doing it in practice and then you see, yeah, I might have changed this a little bit, that a little bit, whatever. So now it's almost 5 years data vault modeling worldwide. And we are now coming to some kind of there are still some iterations, some twitches. There's some different versions going on at the moment where people have slightly different ideas, but the basic stuff is very simple. I have an entity. I can come up with an entity for my source system, and I come to break it up into hubs, identifiers, links, relationship, and satellite context.
Okay. So can I throw a question here? So let's make it a little bit more interactive. So I'll start with the high level logical architecture for data.
Yeah.
So we have source, out of source, we pull data, we throw into a landing area.
Yeah.
Or we can call it a raw area. After raw area, we have a staging area, which Medallion says bronze. And from that, it goes into a transform area. And in transform area, we have two areas. Either we convert into a warehouse, which is a unified data model. It can be a 3NF, it can be a star schema, whatever, but we standardize everything. And then we throw into a semantic layer, which Medallion break into silver and gold. So now for our audience, we have this ideally 3 stages: landing, staging, and transformed. Data vault, and correct me if I'm wrong, data vault and business vault is kind of same thing, right? Just
yeah. I would especially for the audience as well, and make it simple. We're talking about data vault.
Okay, same thing.
I know there are people talking about raw vault and data vault and business vault and source vault, whatever. Let's just talk data vault. And data vault is just the integrated warehouse layer.
Okay.
So in your terminology, the transform layer. And
so that is where
just see it all as one.
Okay. So now we are saying data vault sit. So we have landing as is model. Then we have staging, where we standardize a lot of things. For example, multiple date formats we convert into one format. Special characters we remove it. CDC, all those things we do staging. Then comes transform. So data vault sit into transformed, is it?
Yeah, absolutely. Yeah.
Okay. Now in transformed, as we mentioned, there is a warehousing layer and there is a semantic layer. Semantic layer is very much.
There will always be a semantic layer on top of your transform layer. So out of your data vault, we would always, and I'm an older guy, so about transform, semantic layers, and that kind of stuff. You will create data marts, smaller data sets, your semantic layer, right? Smaller data sets, which can be perfectly fine dimensional, which can be a cube, which can be a flat file, could be whatever.
Yes.
Because it is there. It's the sole purpose of that MART layer, that semantic layer, is present data to a specific user group for specific use.
Absolutely.
That's the only reason we have it. It can be completely virtual, right? Virtualized. can be rebuilt on scratch, over the top, whatever. No problem. The data vault itself, it has the term vault in it, right? Its only sole purpose is to store integrated data, fully auditable, fully traceable. It's just a warehouse layer.
Okay, so it is sitting inside the transform layer. So when you
In your terminology, yes.
yes.
Yeah.
Now when you say it's a warehouse, because for us, warehouse, I can be wrong and we can be wrong, is warehouse as of now is two warehouses. One is Inmon warehouse, second is Kimball warehouse, which you mentioned. Inmon is 3NF, Kimball is Star Schema and Snowflake. Are we saying, you guys are saying that there's a third form of warehouse which is Vault?
I would do there are multiple modeling patterns to use for your warehouse. One is third normal form, one is dimensional, and one is data vault, or let's say ensemble patterns, right? So all the other ones as well. But it's just one form.
Okay.
And interesting, as you mentioned, say, hey, there's an Inman warehouse. Bill Inman said pretty early on, hey, for my warehouse, my concept of a data warehouse, that integrated, subject-oriented, non-volatile, time-variant layer, that warehouse, don't do third normal form, use data vault. He was very early on already saying, my idea of doing it in a third normal form perspective was only there because that's the only reason the only way I had before, and he now very soon supported do it in data vault because he soon saw the benefit of data vault modeling, and it has to do with agility. Whenever there's a change coming in, it's easier to handle that change than it is in any other way of modeling like third normal form or dimensional.
Okay.
So it's an easier way to work on that one.
So you made it really interesting, a person for me who has really come from data warehousing.
Yeah.
So what you're saying here is that Bill is also on the same page, that rather than going towards 3NF, we can have Vault.
Yeah.
Now I will really go down inside the Vault, what Vault is, right? So now let's talk about Vault. Now we have, because we see, okay, why I felt 3NF is a good idea. I'm fine with Star Schema and Snowflake as well, but 3NF for me was much. See, when we have enterprise warehouses and then we have marts, right?
Yeah.
So for me, 3NF warehouse is a very good place because you can dig out golden record. You can you can a lot of do master data and reference. You can place everything into one place. Maybe a product coming from 100 source systems, different pauses, different places. You bring into one table as a row. You summarize into one unified model, right? That was 3NF for me.
Yeah.
Now when you say, so Star Schema is also there, but I always see Star Schema as a business reporting piece, because so that's what I look from my perspective, right?
100% agree on that one. Don't worry.
Okay. Now comes Vault. Now let's go into deep thing. What is Vault? That do you still convert everything into unified? Yeah, please.
But interestingly enough, and it, by the way, it's not surprising, I have this small picture over here.
Yes, I was about to ask that.
Yeah. This is basically what data vault is. I have an entity in a third normal form table. Let's say a customer. And the different colors means that blue is the identifier, right? The business key. Green is association foreign keys, and red, or I think you see it as yellow more, is the context.
So isn't it a fact table?
No, it's not a fact table. It could be a customer table where I say, hey, I'm a customer. I have a relationship to a customer class, to a store, to a product, whatever. And this is my descriptive information about my customer. First name, last name, date of birth, state, all the kind of fun stuff.
So pardon my ignorance. Pardon my ignorance, right? Because what I see here is, we have a star schema. Star schema, we have dimension, we have a fact table. And in fact table, let's bring surrogate key as well. So we can always have a,
Sorry, I'm Dutch, so I'm interrupting a lot. But
No, it's okay. It's okay.
You wanted. If I'm looking at star schemas, the fact table is a whole bunch of foreign keys and context.
Correct.
If I'm looking at dimensions, it's basically a business key and context.
Correct.
Third normal form is a business key, foreign key, and context in one table.
Correct. Correct.
That was given over here. This is business key, foreign keys, context. If I'm looking at a record, I have my business key, I have some foreign keys, I have some context. It's just one row, one record out of this table.
Okay, based on entity.
Based upon the entity, and it is the already integrated entity. I'm talking about, let's say this is customer.
Yes.
I don't care where the customer is coming from. If it's one system or two systems or three systems, I don't care. And it's just there.
Okay, let me throw one more question here. This is becoming very interesting, actually. Don't mind my straight questions.
Just ask the question. Don't worry.
Yeah. So, are we talking about entity or we are talking about entity type? Because entity type is one layer above. Customer.
I would say we're talking about. I'm just thinking. I think we're talking about entities. This is a customer entity. I don't care where it's coming from. One system, two system, three system. I always call this one entity.
Okay. So now, So what difference I can see here is, in fact table, you normally have all the dimension primary keys into it as a foreign key.
Foreign key, yeah.
And then you create a surrogate key on top of it, and then you have a lot of context columns over there, and you end up creating Myers and XYZ over there. Here, the core difference I can see, because over there, fact table is based on the business requirement. If it is a data mart, you end up creating very few fact table based on everything. All dimensions connect with fact table.
Yeah.
Here we are talking about entities. So what we are saying here is, okay. So once we have the ERD diagram, in ERD diagram, we have a logical model. In logical model, we have the entities. So are we saying
basically, that? I'm looking for logical models, and I try. It is an entity, but we refer to it from our ensemble modeling. We have core business concepts.
Okay.
And a core business concept is everything which is important for the business.
Okay.
And we don't care from our modeling perspective. If I'm starting modeling, I don't care about any source system at all.
Okay.
I do workshop with business people and just ask information about, tell me about what your organization is doing, what's going on. And they tell me what their organization is, what their business process is. And I'm just listening and just thinking about, okay, you're talking about there's a customer walking into a store, doing a sale with an employee, their products on a sale. So I'm listening and thinking, okay, we have a customer, we have an employee, we have a sale, we have a product. Those are the core business concepts, entities I work from.
Okay, so you end up, so are we saying that you bring all, because we have, for example, 10 source system, 10 source system have their own 3NF coming. Yeah. Those 3NF, so your right image is not a Bill Inman 3NF, it's a source 3NF, is it? Because Bill Inman bring 10 source system 3NF into one 3NF.
Yeah. We talk about the one. Yeah.
You are one. So you do transform into 3NF, which is
I don't transform in thinking only.
Okay, only thinking.
Only thinking.
Okay, so you end up creating the left one, which is your vault entity one. Where is this?
Basically what we're doing, and that's what the speaker is saying, let's assume we have an entity. I don't care if it's coming from 1, 2, or 3, or 4, or 5, 10,000 sources.
Okay.
This is my business concept. This is how it looks like. And I'm going to transform this one and to say, remember I said data vault modeling or the ensemble modeling is breaking up things that are changing and things that are non-changing. What is not changing? Identifiers. So we store the identifier, the business key, separate from the foreign keys, the relationships. This is non-changing, and this is the context. in satellites. So we take the one entity, we're breaking it up into smaller pieces, which we call
Okay.
unified decomposition. And if we do correctly, we can also fold it back into the origin entity again.
You have opened more another Pandora box. So what you're saying is your left one entity is in logical thing. Physical is on your right, is it?
This would be in the end a physical one. Yeah.
Left one is a logical one, is it?
Yeah.
But
it's only for thinking.
Logical, na? Okay. So what you're saying is, rather than converting multiple 3NF into one 3NF, first you are denormalizing into an entity one. That what customer need. Once you understand that, you create a logical entity and one denormal, because this bottom one is denormalized format. You convert the requirement to a denormalize and then you normalize it.
Yeah, sort of. Only it's a mind exercise more than it's a physical exercise.
Yeah. So because when you're talking to customer requirement, you find out the entities from customer requirement.
Yeah.
If there are 10 entities, you will end up creating 10 lines like this, right?
If they're talking about 10 entities, I have 10 core business concepts.
Correct.
I will have 10 of these, what we call ensembles, which basically the same, only decomposed, if I'm looking in detail, but also 10 of these.
10 of these. So 1 to 1. Yeah. Now, all these 10s, will those be able to connect to each other?
Yeah, because the relationships, well, as far as the relationship says, these should all connect to each other.
Then there's a challenge, because this right one is your foreign key. So I have 10 of these small data models.
Yeah.
And I have foreign keys. If I join foreign key to foreign key, I will have a Cartesian. So how to handle that?
By default, all my relationships, which I'm separating out, are by default many-to-many relationships.
Correct. So it's a many-to-many relationship, right? So it's a Cartesian.
By default, yes.
By default, yes.
By default.
Yes.
If I want to say for cardinality reason, it should be a one-to-one or a one-to-many or whatever. Correct. I need to do something extra to say, oh, by the way, because there's another one over here, right? Yes. It's that foreign key is referring to another one. Say the relationship between this identifier and the other one should be one-to-one.
Yes.
If I want to say that one, I need to describe that relationship to say, oh, as soon as I, as a customer, are related to a new product, which is not allowed, let's say it's not allowed, then the old relationship between me and that product should be end dated. So I need to describe that relationship.
Fine.
So, the cool thing about it is remember, if you do relational modeling, if you are in third norm form and you have a many-to-many relationship,
you can't have it in 3NF.
You can't have it, so you need to create an associated entity in between.
Interim in the middle.
Yeah.
So you have to create interim over here.
In Data Vault, actually, we don't care. All our relationships are just many-to-many by default, technically spoken.
Oh, by default. Then Cartesian will come now. So how you will handle Cartesian data?
Well, the thing is, if I need to prevent, because basically, let's be on the sales example. One sale, many products, one product or many sales, many-to-many. So what do we do in third norm form? We create that associated entity.
Correct.
Product on sale or sale line, whatever it's going to be called, we're going to create one. We just say the product and the sale are related to each other with a link, with a relationship table. But we add that product on sale identity, that associated entity, as a third party into that relationship. And that third party in the relationship, so the product on sale one, going to say, I am telling you something about this particular product on this particular sale. So basically making it logically a one-to-many.
Okay, so you're bringing another one into the middle.
Yep.
So that
still technically the relationships are many-to-many still.
Yeah, but as there are
logically, I can create that one-to-many.
Yeah. Okay. Fair enough.
Or one-to-one or whatever.
Fair enough. Okay. Okay.
So what we say, that's why I said above here, right? Think different. Using Data Vault or Focal Point or any of the Ensemble is a different way of thinking. It's
Hmm.
not anymore about fact and dimensions.
Yeah.
Because let's be honest, you can have a fact table where you can have a whole bunch of dimensions to it, and not all dimensions are available. So you get your -1 unknown part, right?
Yeah. Yeah.
We don't have unknowns because a relationship is only a relationship if there is a relationship. You cannot relate to something you don't know.
Yeah. Correct.
So we don't have it. The other thing we don't have either is we don't want to have a lot of redundancy in. So we need to take care of that one as well. So we get more relationship tables. But remember, the only reason why we're doing it is to store the data. It's not for reporting purposes. It's
Okay.
not to support a business process. It's not operational. It really is the warehouse purpose.
Okay.
And that different way of thinking makes your life a lot easier. Should be.
Yeah. Okay. Let me throw few more questions onto it. So once you convert this, by the way, this looks like a star schema. Until you don't understand that middle one is a business
Yeah,
key,
but
right?
again,
A
this is
foreign
not a
key.
star schema, right? This is really identifier,
Yeah,
relationships,
yeah, yeah, yeah. Yeah.
context. Yeah.
I'm just joking around. I'm saying
Yeah, yeah,
it's
yeah,
just
yeah, yeah.
looking this see is a star schema. Okay, now how about as how you're managing the history then? You have 5 tables there. How
Yeah.
you're managing history? Because you don't have a concept of dimension, right? SCD1, SCD2, SCD3, or you have it.
Oh, no, we have complete history, not on the identifier, not on the
Okay.
relationship. Because let's be honest, an identifier business key just is. They're very zen, right? I am
Mm-hmm.
there.
Mm-hmm.
Relationships, they are there as well. The only
Yeah.
thing where we have history on is on context. Context is being stored in the satellite, and this is also our satellite tables, our satellite construct really looks like a dimensional table. It has a two-part
Okay.
key.
Okay.
One referring what are you referring to, which business key you're referring to,
Hmm.
and a technical, and that's important, a technical timestamp. When did you wrote this piece of context?
Yes. Hmm.
And if you see that part, that is from a technical level, we have full-blown historical information. We also said, apart from the technical timestamp, when did we wrote down this information, so keeping that historical level,
Hmm.
we also tell people always store a business timestamp with the context.
Yes, of course.
Because your business timestamp is probably going to be the one you're going to use in your dimensional model in the end.
Correct. Correct. Okay, now, so what you have done is right now on your left side, you have an entity which has one business key, which has 2 foreign keys,
Yeah,
and which has 2 columns, which are contextual columns.
yeah.
So
And
what?
it's just third normal form, that whenever there's a change coming, it's just overriding the old value.
Yeah. So what you
Right?
did is you converted those 5 into 5 tables,
Yeah,
right? And 5 tables, one table has the business key.
yeah.
One foreign key you create in another table, second foreign key you create in another table, and other one columns you created other tables with the business key in.
I have I have the freedom on context. I have freedom to say I put everything in one satellite or multiple ones or whatever. I have freedom over there, and I
Okay.
can make the choice to say I want to have logistic information separate from financial information.
Ah,
It's
okay.
describing the same business key, but I want to separate those. Make my life easy getting the data out again.
Fair enough. So what you're trying to say is as the business key, the granularity remains same, then it is on to the modeler to convert into as many tables or keep one table. Does not matter because granularity is same. Correct?
Basically, yeah, yeah.
Okay.
Basically, yeah, absolutely, yeah.
So now you're so the context side I understand easily. Now business key I also the foreign key tables which you have created. Why you separated foreign key into multiple tables?
Well,
And is there any other column in that foreign key tables?
now, the foreign key table only holds the full relationship. And here I just created two, but it could also be one. If you say, and that's for instance, let's go to the sales example, right? if I'm going for a sale has a relationship to customer, to store, to employee, and to products.
Correct.
Out of my sale, which is an event, which is a transaction, so it has its own identity, right? A sales ID, it has context, and that relationship. I will create two links out of that one, two relationship tables.
Yeah.
One relationship table is referring to store, employee, and customer, and one relationship table will go to product, including that line item to that one. So I will create two. But if you look at it from a terminal form perspective, it has a foreign key to customer, foreign key to store, foreign key to employee, foreign key to product. It has 4 foreign keys. Well, also, to sale line item, not the product, right? Many. So it has 4 foreign keys, and it will end up with 2 relationship tables out of my sale. It has 2 links.
So you are
because
saying
I can combine foreign keys into one relationship table if we say these all belong together. And that's basically what we need to do. Say, hey, what is all belonging together? What's all happening at the same time? What's the relationship incomplete? It's going to be one relationship table.
I got it. If 2 foreign keys are referring to same hierarchy, then you keep into the one foreign key table.
Yeah. So our link table, our foreign key table, right? Association can hold 2 foreign keys, or 3 or 4 or 5, as many as coming together.
And that will become a composite key, correct?
That will be the combination of all the foreign keys, right? That makes it unique.
Yeah, that makes it unique. Now, you have this 1, 3 in a sitting. Now, let's say, as we refer to our previous example, 10 sets are there, right?
Yeah.
When we join together, we join to the composite key, or we can join any of the key of those, any of the column of those composite key.
Normally, what you would do when your starting point would always be your identifier, your business key.
Okay.
And then you can say, for this business key, give me what a relationship do I have with other stuff. And then referring to the other one. So the joins always not from out a link, not from out a foreign key situation. You always start from a business key.
Okay. And business keys definitely have the most granular combination.
Yep. On the lowest level.
Lowest
level. We also, very important, when we are modeling our logical model, our business concepts, we don't model generic. We model in the language of the business.
Okay.
What we mean is from a, you probably heard of something like an involved party or arrangement. Nobody in the business understands what an involved party or an arrangement is. So we don't model it. So we model prospects, we model customers, we model suppliers, we model whatever. We model it in a terminology the business understands.
Okay. So it means you are totally ignoring surrogate key. No concept of surrogate key in your model, correct?
Well, there are, because we are using a technical surrogate key everywhere. We're doing the same stuff. So our hub tables, where we store the business key, basically has 4 attributes.
Yeah.
A surrogate key, just a warehouse key, the business key itself, and the business key could be concatenation, everything what is needed together to make it 100% unique.
Yes.
It has an inscription date timestamp, when did we load that identifier, and has an audit ID, where it's coming from. So metadata. And that surrogate ID, which is one-to-one with your actual business key, is going to be used in our link table, relationship tables, and in our context tables.
Fair enough. So there is a surrogate key.
Okay. So basically the same what you do, right? If you do dimension, get a surrogate ID on your dimension, right? To get your historical information, and a surrogate ID is going to be used in your fact table. We do the same stuff. Okay.
Fair enough. So the angle I am seeing here is Data Vault is, my apologies if I say something wrong and you don't like it. So for me, it looked like a star schema, but built based on entities, business requirement, rather than from bottom to up. And you have
Yes,
broken down.
more or less. But basically, what you're saying, right? Some people refer to Datavault as a hybrid between third norm form and dimensional.
Correct, correct, correct. That's what I was about to say, that you have broken down fact tables into your right pieces.
But also, we also break down dimension tables into the same
Yeah, correct,
construct.
correct, correct, correct. Fact and dimension both, you have
So
broken down into your piece.
basically, what we're doing is really to say we make our life easy as we can, because again, what is always a hard thing in data warehousing when there's a change coming? I worked for a customer long time ago, financial industry, and they said, Remco, could you create a new dimension for customers for the finance department? And I said, wait a minute, we are doing full on Kimball, we are doing full on conform dimensions. Why? And they said to me, yeah, it's easier for now, for us, to recreate or create a new custom dimension for the finance department than to see, oh, we already have one and we need to change it. And the idea behind it is to change it should be okay. Theoretical should be okay, but in practice, everybody created new dimensions, so we don't have conform dimension anymore, right? Because let's be honest, what are you doing if you're adding, let's say, adding a new hierarchy, whatever, in a dimensional table? You would add extra columns to your dimension table. But there's already data in the table. What are you going to do with the columns you add? Are you going to leave them empty? Are you going to reload them or fill them or whatever? What you're doing is you're changing history, basically.
Absolutely, yes. Absolutely,
And
yes.
that is something where that's why out of the very need for auditable and traceable data, all the ensemble patterns, including data vaults, came. Because it's easy when you say, oh, I need to add a new hierarchy or I need to add context. It's so easy to say, okay, it's still referring to the same identifier, to the same business key. What I'm going to do, I'm going to add a new context table. It doesn't impact anything at all. I'm just going to add a new table for it.
What if a column or any contact, any attribute comes which change your granularity? Then what will happen?
Why would it change my granularity?
Because last time when you were pulling something, it was data was one hierarchy up, right? And now business has changed its data model. They brought next level of data in their source system, like product line item, right? Maybe it's a good example or not, but product line item is there. Maybe they break down into further next level. So granularity changes in source system.
But the thing is, just thinking about it. If you say it's on a relationship level, it's on links. That's not a problem.
Okay.
I can create a new link. I can create a new relationship. So if you go say, oh, I have some kind of a product hierarchy, right? Product group, product line item. It's either going to say we're all product and we are creating a hierarchy relationship on the product table, so recursive relationship. Not a problem. If you say, well, very important for us, we could have, well, let's say we have 3 entities, product group, product line, and now say we have product line item. Then it could be its own business concept with its own relationship.
Okay.
That's one solution. If you say, well, we are going to say for whatever reason, and that's there's a misconception in data modeling world, in data vault modeling world at least. Let's assume that we have an employee and the employee has a mobile phone, but we also want to store another mobile phone number for that customer, for that employee, because he has 2 phones at the same time. That you cannot store to say, I am one customer and my contacts, the phone number, there are 2. You cannot store that anyway. Some people think you can make our context table multi-active, so I can have multiple active records, but it doesn't fit the paradigm anymore. Because in third norm form, you don't have multi-active at all. It
Okay.
doesn't exist. And we are thinking the same part. So we cannot have multi-activity somewhere over here. We are going the wrong direction. What's happening is to say, if you are are an employee and you're having you're using your own mobile phone and said, well, you know what, Mustafa, I'm going to give you a mobile phone for my work, for your work. What's happening? Yes, you have two phone numbers, but one is referring to your personal one and the other one is your work one. It's just a new attribute. It's not just one phone number with two different types, but they are existing next to each other. There will be two attributes in the same table. Home phone,
Okay. So if
home
I
phone or
end up,
private phone and work phone. It
got
will
it.
be an extra attribute.
It'll be a new attribute.
Yeah, yeah.
So it means if I end up having 4 or 5 my own numbers, then you are saying context table will keep increasing. It won't impact the whole piece.
Yeah, and the thing is, and there's a lot of discussion on this particular topic, so it's interesting, but it's very simple. If you have 4 or 5 different phone numbers, you probably can refer to each phone number from a certain perspective. This is my private one, this is my wife's, this
Correct.
is my
Correct.
home, this is
Correct.
my kids' one, this one. So we can store it. If you can say, I cannot make the distinction, it's just a mobile phone, period. But I have 5 of them. You still should be able, because I don't think if it's coming over time, it's not a problem, right? This is the first one I know, this is the second one, the second one, second one. If it's all coming one at the same time, and this is where some people are having a discussion, I always say, if someone has 5 different phone numbers, there's always one you can take out of those 5 to say, this is the preferred one.
Primary one.
Then just say, primary phone number. If you cannot make any distinction about the other one, just store them as a string altogether. Because thinking from a reporting perspective, from a business perspective, are you really going to say to business people, oh, I want to reach out to Mustafa, here are 5 phone numbers. They're going to ask you, the first thing, the business people, the marketing manager, going to say, which phone number do I need to call to get Mustafa on the line?
No,
What is the order of phone numbers I need to try? They'll ask you, said, I don't know, here 5.
No, so
That is not how it's working.
now I can throw a different angle from this example, right? Yes, in an organization, phone number is not important, but if you go into a telco really want to understand which phone numbers are active, which phone numbers are mostly used, which phone number this guy is calling more than 20 minutes or 30 minutes, which is a quick one. So those
But you're now reversing. Now you're saying, I don't care the customer who the customer name is, but for instance, I just care about the phone number. The phone number is my identification. That's my entrance.
Okay. Got it.
And what I was referring to is I have an employee or a customer or a guest or a friend or whatever. And a friend, I need to reach out to the friend.
Got it.
Has 5 different phone numbers. No. Friend is my entry point. And for a telco, phone number is the entry point.
Okay. Fair enough.
And the entry point says, hey, I'm a phone number. Whose phone number is it? Oh, I have to go to the contract to see who's the customer.
Got it. I got it. Okay. I think we have a time check. We have actually this discussion is going so good. Yes, we only have 10-12 minutes. So let me go one level up. Are we missing any obvious thing you want to highlight before I go toward the different angle of looking into it?
Well, I would say the most important thing is on all the approach, right? I love this way of modeling because it's very agile. I can change a lot. I can easily add in some stuff. Also, this is just Data Vault, but we also have some. If you want to look into it further, don't only look for Data Vault, but also we have the Elm approach, and I'll send you the links so you can add it with your podcast, right? There's an approach to say, this is how we work together with business people. And I think that's the most important one. Modeling is doing something with business people together. These are the steps you need to take to go to get a full-blown data vault model. Also, I'd love to refer to, because you're already talking about logical model, conceptual model, right? earlier this year, I had a good contact with Steve Homan, good friend, and he's no longer talking about conceptual modeling, logical modeling, physical modeling. He says, why don't we call it, I want to align, I get an aligned model, or I want to be aligned, I want to be refined, I want to refine, and I want to design. And why I like it is because I'm always saying, if I'm to go into a business, I want to be aligned with you in the business. Technically, IT, conceptual model. Then I can say, okay, I'm aligned with the business. Let's go and refine the model. In other words, I know your business concept. I want to know more about the relationships. I want to know more about a little bit about the context already, but I want to know more. IT terminology, logical model. Cardinality comes in place, all that kind of fun stuff. And in the end, we need to make it physical in design. But if you stay away from IT terminology when you're talking to business people, because we do a data model to reflect, to map the business, right? That's what we want to do. To stay away from IT terminology, you get that communication with business people, which makes your data model way more robust.
Okay.
And I don't mind changes, but my data warehouse model should be as consistent, especially on identifiers and relationships, right? Hubs and links should be as consistent as we can. And I only can do it if I stay away from source systems. Think about if you are basing your data warehouse model based upon a source system or multiple source systems, the landscape of sources you have nowadays in your organization is different than the one you will have next year and the year after and the year after. If you are basing your model upon source systems, you're constantly changing your model.
Agree.
If your your data warehouse model is reflecting the business model, it's not that hard. Because if they are replacing, they're going to introduce Salesforce as new ERP system instead of the other one. It doesn't change anything for the business perspective. It's a
because entity doesn't change. New entity can come, but existing entity cannot change. Entity is an entity.
Exactly. But if you are modeling in line with your source system, you're kind of starting from scratch again.
Yeah. Okay. Okay, I have few more questions. We have only 8 minutes left, unfortunately. But do you have a hard stop?
Not
Okay.
not a really hard stop.
Not a really hard stop. That's good. So a question from the angle of cloud, right? Because we are on cloud.
Yeah.
On cloud, one of the biggest challenge is costing and costing of the compute. What I see in your model, a lot of joins. So are we saying that you want to expose this to the query or BI tool? Because end of the day, we have a BI tool, right? You want to expose this model, or you want to convert that into a semantic model first?
No, there will always be a semantic model on top.
There will always be physical semantic model, not logical.
I would say in the ideal world, it should be a virtual one.
A virtual one. Then, okay.
But from a cost perspective, I completely get it when people say, I'm going to make it physical. Not a problem.
Yeah. Why I'm saying that? Because the moment you pull this data into, you hit a query on a virtual or in a query, right? It pulls everything into memory.
Yep.
When it pulls everything into memory, it has to do joins in the memory. And compute goes like anything. But if you can convert into a semantic layer, most of the time we do try to denormalize the semantic layer. So when you hit it, it's just an IO. It's just a select static from there. So you don't mind.
Not a problem whatsoever. The only thing what I can say, and that's kind of if you have a correct model and keep it simple, which by the way is the hardest thing to do, right? Having a simple model. Yes, you have a bunch of joins, but a couple of things. They are always a direct hit. So you don't have to worry too much about full outer joins and that kind of stuff. So there's no reason to do that one. Because if I have an entry there, I have an entry over there. 100% sure. Right?
Mm-hmm.
If I have an entry in my relationship table, there is an entry over there, which is valid. So I don't have that issue anymore. So I don't need to do that extra check and balances and filter out. So that's one thing. The other thing is the way we always suggest and say, think about your semantic layer differently. And what I mean is, instead of creating big, fat, dimensional data marts,
Mm-hmm.
full historize, so you change dimension type 2, whatever, everything is in. Just think about, what do we really need for this report? And I argue that basically, going back to what Kimball originally said, I want to create a data set fit for a specific user group. That's the only thing I'm doing. I don't try to create the one big fat model anymore. Conform dimensions. Why did we do conform dimensions? We used to do it for integration. Integration is already done in your vault layer, in your warehouse layer. I don't need to do it again. But it also means that my dimension for marketing and my dimension for finance could be very small dimensions, for instance. Right? The two different departments, they get only their own information, smaller data set. Another thing is historical information. How many people in the organization really need to have on a dimension level full type 2 dimensions? I would argue less than 10% of the organization really need it. Only the analyst might need it because they want to see back in history over time what was the situation on a product level as it was back in the days or whatever. They might, a very small set.
So what you're
All
saying
rest
is,
just want to see current information.
no, what you're saying is, yeah, I can absolutely agree with you if you're saying that from this data model, if we end up creating a semantic model, semantic model is nothing more than what business want, and they want to aggregate for last 10 years of data. Your aggregation is already there. Then how many percentage will really drill down? So you are absolutely right. The people only who drill down if the dashboard shows a red arrow down there. It's a red arrow, then normally you start drilling down. If it is always green arrow, then nobody drills down because it's all positive, right?
Absolutely, yeah.
Okay.
No, so I don't do at least, well, I advise always organizations don't do type 2 dimensions anymore. Yes, you have on the facts, you have full historical information, but on the on your dimensions, just do type 1 and basically throw away everything and start over again. I'm not, and if it's from a compute perspective, right? Don't append or try to do some stuff. It's easier. That's why we say virtual in the ideal world, right? It's easy to just throw away, start and load again. That often it's faster than just to add a couple of records and to change it, because then you're getting kind of screwed.
No, but this will come with a challenge. SCD1 will come a challenge like Mustafa as a customer. For last 5 years, my data was written MUSTA PHA, but there was a data quality fix. It was fixed MUSTA FA. So last 3 years, last 2 years, it's correct data. Before that, it was wrong data. But there's a history. If I remove my dimension history, then I cannot go back, right?
Of course you can.
How?
Because what we can do is we have that full historical information in a warehouse layer.
In your layer, okay.
And we can just recreate it to saying, oh, by the way, all the stuff Mustafa did with PH instead of an F, right, which was wrong, but all the stuff now need to refer to the current version we know of that customer. Mustafa with an F.
Okay, got it. So what you're saying is you are proposing star schema as well on top of this in the semantic layer.
Absolutely, or a flat file, or the one attribute set interface, whatever you fully denormal, whatever works.
Then I'm with you. So you are keeping the history in this model.
Yeah.
And
But But there's a big difference between what used to be done and this all the ensemble links, the integration and the historical keeping all the full historical information is done in the warehouse layer. The only difference is with what it was before, that the warehouse layer is not accessible directly for reporting. You always need to have the semantic layer on top.
Correct.
And then get you the opportunity, do I need to integrate again, conform dimensions, or have full historical information again, type 2 dimensions? I argue, probably not. It's also quicker to change, because if someone says, "Oh, by the way, this dimension, I'm not using it anymore, or I only need it this pieces for filtering, and I don't need the rest of the information," so I can recreate the data mart again on the spot, almost on the spot, with the new requirement. And it already has, for instance, all 15-year or 5-year of transactional historical information.
Yeah. Okay. So now let's go towards the closing one, right?
Yep.
So this small data model, which is right on your right side, so we are saying every entity will have this model. So
Yep.
we will have these sets of these small model. As many entities we have in an organization, as many these models will be sitting there.
Yeah.
Okay.
So if you have, for instance, a simple sales model, right, has 8 entities. I have a region, a store, employee, customer, sale line, product, and supplier. 8 entities. If I'm going to vault that one, just going to data vault, I have what we call 8 ensemble, because there's a one-to-one. Also means that I will have 8 tables, 8 hub tables, because they store the identifiers. I have as many as relationship tables as I need. Probably will be 4 or whatever, something like that, and I will have many as context tables as I need. Every identifier, every hub will most likely, on average, have 3 to 7 satellites. 3 to 7 context tables.
Satellite is context table, right?
Context table, yeah. Where we keep the track of the historical changes over time. So Mustafa was P8, Mustafa was F are 2 entries.
Okay, so
it's like slowly changing tattoo.
Okay, got it. So it means in traditional world, in 3NF, we have transaction tables, we have master tables, we have reference table. We have 3 type of tables. So here we have business
We
key.
just look at all the entities, and we don't care about if it's been seen as reference or master or transaction.
Yeah, so you have satellite table, which is context table, you have business key table, and you have foreign key tables. You have these type of tables.
Yep.
Correct? Okay.
Yep.
And this does not limit you to use any database. Does not matter, right?
No, I don't care what database being used. No.
These are all logical models.
It's all logical. It can go physical. I implemented a data vault on SAP HANA environment, Snowflake, not the star schema Snowflake, but Snowflake as a tool is very good on data vault modeling. Oracle, AWS, the cloud, whatever. The only thing is there are differences, right? If you're going into the cloud, the way it's been stored in the cloud physically is different than logically.
Yeah, actually, you have this is a very good session, by the way, Remco, because you have totally changed my mindset.
Being different.
Yeah, because see, you did not counter semantic layer, you counter warehouses.
Yep.
And warehouses is only 3NF warehouse, not star schema and Snow. Because okay, I'm very happy that we are on the same page. I was always on the side where I say star schema should be in semantic layer, not in a transform layer. I was always, but people used to say, no, it has to be in transform layer. I was always on a side that star schema is always business requirement based. So it has to be in semantic. So we are on the same page. Now what you're saying is instead of creating a 3NF, create data vault. And this 3NF is based on the subject area, right? And data vault is based on the entities. So in subject areas, entities can repeat. but in
Correct.
entity model, entity will never repeat.
Will
That's
never repeat. Correct.
that's a takeaway for me as well, because in subject area, customer can be in one place, customer can be in another place, different subject areas, right?
Mm-hmm.
Okay. Okay. And here we are not looking for 3NF, right? It is business key.
I'm not looking for 3NF. I'm not looking, I don't, to be honest, I really, when I'm starting off with customers, I really start off with the business people doing workshops. I don't care about how their information is stored. In the end, I do care about how we are going to store it in a warehouse. And I'm a big fan of, well, no surprise, of data vault modeling. But I can easily go for an anchor modeling or focal point modeling as well if there are reasons for it. There are different reasons, but that's a completely different topic. Uh, but I'm a big fan of this way of working because it's helping me to store information in a way that I don't need to change it over and over again. And I tell people I'm a data modeler, but I'm a lazy one. I only want to create a data model one time. And yes, I will make some small adjustments, but I don't want to start over and over again. When I was working for that one customer and I need to have the fourth customer dimension for the finance department, I think, yeah, going through the same job over and over again, just because it is easier to do recreate than to whatever. If I'm doing third normal form, you don't have any issue. You don't have a choice. You cannot create a fourth customer entity in third normal form, right? You need to do it once. So then you have a whole different issue. So I don't go there. I make my life easy as I can.
Okay, awesome. I think this was a great session, Remco. Thank you again, Remco. It was pleasure talking to you, and it was a great session. I hope our audience really liked it, will like it, will understand. I'm sure if I could understand Data Vault, people would have a good time to listen to this one. Thank you so much again.
Yeah, thank you again, Mustafa, for having me. I hope indeed your audience likes it. If there are questions, they can draw me a line on LinkedIn. I also give you the two links to two websites which have interesting information about modeling. Not so much about selling stuff, but it really data modeling stuff, which is interesting.
No, so I will add that into my podcast thing.
Perfect.
And if you have some very precise diagrams, you can send it to me. I can attach into my LinkedIn post as well.
I will definitely make this one a more nicer one.
No, it's okay. Thank you so much. Have a good weekend.
Okay, cool. Have a great day. Bye bye.
Bye bye.